Okay, in this video we are going to be doing a few more examples of the algorithm design and branching and looping and all of that. So the overall goal of this video is to give you a new example of a loop and a new example of branching and a new example of doing an algorithm design. So in the end, what we're really looking for is decisions to be made, deciding on what loops need to be done, and then just deciding on how to approach a single problem. So I want to give a quick example of how when we are working with the branching. Change my pencil color to black. And so what I'm going to start with is like identifying plants. I know that sounds like really, oh, this has nothing to do with geomatics, but it's actually like very, very important to geomatics, especially in the remote sensing world. So what I deal with a lot of vegetation. So being able to identify my plants is really important. So my original starting point is to have, for example, if I'm going to categorize it, I'm going to have plants. Then from here, I'm going to have an if statement, and in our algorithm design, because you guys have watched my other video, it would actually be a decision, which is a triangle. And there is two options. So the one side here for a plant is don't make seeds. So let's say, for example, the if statement is do make seeds. So this side is don't, and this side is going to be do make seeds. Now, again is seeds. That's what goes in there. So on this side, this is my true statement, and on this side, this is my false statement, okay? So we have a choice, whether it makes seeds or it doesn't make seeds. So from here, if it doesn't make seeds, I have another if statement. And from here it is, the statement here is about roots, stems, or leaves. So does it have, if it doesn't make seeds, does it have roots, stems, or leaves? If it is no, so this is no, so again this is the false. And if it is true, it is yes, it has those. This is my true. And so on the no side, I end up with something like LJ. On my true side, I end up with something like moss. Okay. Then on the true side of the plants, I have, does it make seeds? Yes, it is true, it does make seeds. Then I have another branch that comes off over here, and I have is flowers. Does it have flowers? So on this side, if there are no flowers, which is my false, and then on this side, my yes, it has flowers, and that is my true. So here, go down. If it does not have flowers, I end up with conifers. Then on the yes, I have another option that happens, and it asks if it is a tree. So if it is a tree, if it is true, I get my deciduous trees. And then on this side, if it is no, I get a false, and that is my plants. So this looks like what branching does. So it's yes or no. I have to make a decision. Does it do this or this? And then I can classify it based on that. So how would I write this out in an algorithm design? Well, this one, it comes down to indicating the yes or no's. So my first step in this one is to identify if it has seeds or not. So if seeds is equal to true, or equal to 1 actually. Let me erase that. So if seeds is equal to 1, which means it is true, then I'm going to have another if statement, right? So then, because I'm on this side, come down into here. So then, if flowers equals true, then, so it's flowers, so it comes down here. Now we got another if, then if tree equals 1, then I can say output equals deciduous. Then I have to go back here because this is all like a then else. So if then else. So I'm already at this level over here. So from my tree, I'm saying false. So now it is a plant. Then, or sorry, else if this should be then. I'm missing a then. Then that should be indented. So please indent that. This will also be indented. No, that one's not. Sorry. Missing one word and then it throws me right off. This is how coding works, right? so I can actually stop that if then, and this is kind of an end here, right? So I can, in some software, you actually have to say it's an end. So I can have if then and then end, and that's the end of that if statement because there's no else. So if it is true, there's nothing else besides that. But if it's false, so I'm looking at this one. If tree is no, that it's not an end. Ha! This is why I enjoy doing this all online because now I can just keep going back and keep overwriting this if I really wanted to. But I'm going to let you guys experience what it would be like to have me in the classroom. All right. So if this should be indented, then output deciduous else, because if this is false, it's going to come down here and then else output plants. Output equals plants. Then we can say end, because this is all indented. These two are indented. This is an end. Then I can go back to this one, this then. So I go back up here and I'm looking at flowers. That was tree, and this one up here. So if then, so else, if flowers is not equals to 1, we say else, this one is not indented. Else, it's going to be no. And we're going to have conifers. Else output equals conifers. And then end. And then we're going to move back up to seeds. So we've done tree, we've done flowers, and now we're back up to seeds. So now what happens if it's false? So now we got to deal with this then. And that then we have else. And it comes down to these root stems and leaves. So we're going to call it, or we don't have to say anything because it just says else. We have two options, and that is, so else, if this, else if, because we have to make that decision, roots, stems, and leaves is equal to 1. If this one becomes true, then it's going to be moss. There needs to be a then there. I mean, so the software always, when you do programming, a lot of this goes into programming languages. So when you do programming, it actually like tags it nowadays. Like you hardly have to even debug any code because it's like, oh, you have an error. Like, oh yes, I do. I'm missing a word. so if that, then the output is moss, else. Then we have the no, so we go to LJ, else, output equals LJ. So then this one ends, and then this one is also at an end. So now let's double check. Let's make sure that we've got everything. So we go down to tree and we have a decision at tree. So right here, and it goes tree, then else, and. So there's the tree. Then we have flowers. We have yes or no. So flowers is up here. So flowers, and then else, conifers, and. Okay. Then we have, so we went up to here to seeds. So if we have seeds, then, and then we have an else and an end that comes with that. And then on this side of the equation, we have if, then, else, and there we go. So this is how we would view this as, I'll keep it at yellow, as our options. So for example, now what the computer does, because the computer cannot, well, there's certainly software that you can use visuals like this, but when it gets put in like this is actually breaking it into an algorithm. So if I were to take an unknown plant and I stuck it in there and I say, oh yes, okay, first thing first, I'm looking whether it has seeds. Does it have seeds? Yes, it does. So I'm going to follow this path here. Does it have flowers? Yes, it does. So I'm going to follow it there. Is it a tree? No, it is not. So I'm going to find out that it is, well, plant. I say plant there. Just, generic green plant. So that's what we'll call it that. They actually say angiosperms in the thing that I'm looking at right now, but we won't get into the Latin on that. So now I can follow this. No matter what I do, if I am looking at a fungus, for example, be like, okay, well, I'm coming here, or no, not a fungus, but like an algae, and I come here and I'm like, does it have root, stems, and leaves? No, it does not, so therefore I'm going to follow it down there, and then I've got my answer. So instead of having to make decisions way back on my own at the beginning, I can actually just follow this direct chart. So this is branching. This is actually a more complex branching, but I thought I'd better introduce something a little bit more complex to you guys and then show you how it's actually written out if you ever have to do some coding. So with that, I'm going to save this so that you guys have it. Here, teaching. And then we're going to call this one branching. There we go. All right, so now that we've saved that one as a PNG file, click that off. So the next thing that I was going to talk about in here as well was looping. So any kind of loop that we're looking at here is when we have to keep going back and doing something. So I'm going to use an angle, for example. So if you had to keep making decisions and going back and testing it again and again and again. So looping is also a very important thing, especially when it comes to algorithm design. Also branching is very important in algorithm design because there's always lots of decisions to make. So with looping, let's say I'm going to be looking at an angle and whether it's greater than 360. So a person can put in a number, any number at all, and then they have to make sure that it's less than 360 to make it into a circle. So let's take a look at this. So let's say that the input is unknown. Okay, so there's always input. That's what it is, right? Input, processing, output. So the input's unknown, but the user puts it in. And this is kind of step one. Step two, I need to test is the angle less than 360. Then, my third step is if it is, continue. And then continue program, or continue whatever calculation you are doing. If it is not, I need to subtract 360. Then, again, this is going to bring it down like a full circle, right? So because a full circle is 360, so no matter how many times you go around, you're still going to end up on the same spot on the circle, right? So that's something important to remember. So the next step is I subtract 360. What do I have to do? I have to test, is the angle less than 360? If it is, I continue the program, right? So same as step 3. Then, if it is not, 6, 7, that's 7. If it is not, and you subtract 360, this is same as 4. And then I continue to repeat until the angle is less than 360. So what does this looping look like? So what I have done here is I have identified, okay, here is a decision that needs to be made, and here is an operation that I have to apply even when that decision is happening. And I have to continue to apply it until it is good. So another good example is if you have a bunch of numbers and you're trying to figure out the average. So you put in a whole bunch of numbers and you need to figure out the average, but the computer does not know that you are, they don't know how many numbers you have. So it will keep going back and keep asking you until you do something that it tells you to stop, right? So you repeat until you tell it to stop. So what does this look like? So here, I'm going to identify again between do and while. So the do loop means you do something and then you operate. So that would be first. So let's take a look at that. So my user input. So the first thing is input. Right, so then I'm going to test for the value. And then, so input a value, test for the value. So you can kind of think of it as a decision, like we just finished talking about, right? So if it is less than 360, continue. If it is greater than 360, what I'm going to do is subtract angle, subtract 360, and then I'm going to test for the value. And then I go through the same thing, right? So then I have the yes or no, and then it continues. So what my loop here looks like is it looks like I'm actually, the only thing I'm doing first is this. So I input a value, and then I can say that do test for this first, or I could say while, right? So do, in this case, do, so here's what I'm going to show you what happens. So do if angle is less than 360, then continue. Else, so this is if it's greater than 360, angle minus 360, and that's going to be end here. Then, so that's the do, so it does this first, and then it's going to subtract that, and then we're going to say until angle is less than 360, and then end. So that's do. Now I'm going to need a little bit more space here, so let's just kind of erase some of this. Looks like there's little pieces there. So in return now, instead of doing it that way, what if we did while? So the person inputs their things. So while angle is, because I'm testing first, is greater than 360. Repeat is what we use for while. Repeat angle minus 360. and then end. Do you see what I've done there? This one looks a lot more efficient in this particular case than this one over here. It just depends on how your brain thinks. So either way just works fine. You can end up, like, efficiency of programming is going to be a debate for everybody for a very long time. Everybody's going to have their own opinion about what's more efficient and what's not. So whichever one you want to do, but this is just how they look different. So you can see how I can't do much with that angle in my do. Then, so I have to have this if statement to start with. But let's say that I had to add something first. So if there was an adding, I'd have to do that here above that if statement, where the while it doesn't work as well, because now I have to do it up here, and I can't repeat that every single time. I can't repeat a calculation unless this is showing up as a positive. So, so that's looping. And so I'm going to save this one as well, just to kind of give you an idea here. And then branching, and this one is looping. And then last of all, so I'm going to delete this one. Then last but not least is the algorithm design. So this is where you can end up with all of these options. So I'm going to bring up since your assignment is about making cookies, let's do it that way. So, or not making cookies, but using algorithms, using recipes. And the reason I'm using recipes in this case is not because that we're going to learn how to cook. It's just that because at this stage you've only had about a week and a half of geomatics training, so I can't throw you a scanning, like a laser scanning calibration, and say, okay, now you got to write an algorithm for that, because you just don't have the math background to do that. So we're just sticking with something really simple for now. So with algorithms, I'm going to draw this one with the symbols just to kind of help you out here. And I'm going to do something really simple in this one, just because you guys have a little bit more complicated ones. And you've already seen some of the complicated, like, looping and if-else statements and such already. So my first recipe is, or my only recipe that I'm going to go through is, let's say, chocolate chip cookies. So normally you would have a triangle, not a diamond. You would have a triangle for each input value. So some software does have triangles like this. Some will allow you to use triangles like that. I'm okay with either. Either works for me. The thing is usually you would have every ingredient in its own triangle. So for example, this one might be flour. This is sugar. Just make sure you stick with the same type here. So we have baking powder. Then we might have salt. And this one might be brown sugar. Maybe this one here is going to be white sugar. And eggs. Notice that I'm not getting really particular in this case with, like, sizing. That stuff is meant for the recipe itself. This is really just to get an idea. It's like, oh, okay, if I input a certain number for each of these, I'm going to end up getting an output. So I have eggs, maybe I have butter. Trying to think what else goes in chocolate chip cookies. I think that's about it. So what I'm going to do first is, these are all my input, and we can just turn this one around. But I'm going to say, I'm going to put all of these. Oh, I need chocolate chips, don't I? But we'll do the main part first. And say mix together. So all of those go into this. And of course, if you have a nice software that uses actual lines and such, you can do like nice little 90-degree lines. Then we are going to have mixed together. Those are going to go in a bowl. Guess what? These ones are going to go into their own bowl. And And so they're going to come together here. And then we're going to, for those of us who enjoy this, we're going to make a well. And then this one gets input here. And I say mix together. And then there is another ingredient that's really important for chocolate chip cookies is chocolate chips. So we're going to take the chocolate chips and I'm going to fold in chocolate chips. You don't need to write that because it's already indicated there. So I just need to fold them in. Once they're folded in, then somewhere over here I have spray pans, right? So I have some pans over here that have kind of done their own thing. Then what I'm going to do here is I'm going to make balls. So I'm going to make little balls with my chocolate chip cookies. From those little balls that I'm making here, notice that I've really kept these simple. I haven't gone into a lot of detail. I already indicate I'm more in detail with my ingredients than I am really with this. If there's something very specific like fold in or whisk in or those kinds of things, then you definitely state that. Now I'm going to make balls, and then my decision here is this is enough chocolate chips, right? Do I have enough chocolate chips? Do the balls actually look like they have enough chocolate chips? If yes, I'm going to go up here and I am going to put on pans. So pans are going to go in here. Then from there, I'm going to put in oven. Maybe a preheat oven has been over here. That's in the box. So put in oven. Then here's a test. Are they brown enough? If no, keep in the oven. And I keep checking it, and I keep checking it, and I keep checking it. If yes, I'm going to place on a rack. And then my stop sign comes here. I have chocolate chip cookies. It's the end. But what happens over here? So it says if there's enough chocolate chips. If there's not enough chocolate chips, no, then what do? Well, I'm crazy. So what I'm going to do is I'm going to roll. Oh, sorry. I'm going to roll balls in chocolate chips. Why not, right? They're going to stick. So now we have extra chocolate chips. Now where does this tie back to? Does it go back to balls? No, it doesn't, because I've already input the balls there. So this actually goes, once it's done, is going to join this yes line, and it's going to go into pans. So you have a choice on how you want to represent that. Oops, that wasn't supposed to happen. So we're going to go from here, and this is, you can either join it like this, or you can join it. So this is all attached, right? You guys may not be able to see that lower line there. It's all attached to there, and then just goes up to pans. So this is an algorithm design. Right now it looks really messy because I did it by hand. I would hope you guys would use rulers. My little tablet thing doesn't have a ruler on it. It doesn't even have guidelines on it. So, so anyway, but making sure that you put in all the ingredients separately, like as they are extra, going through and identifying where things are together. So if I put eggs and butter here and then I say make a well and then I'm put together, this doesn't make sense. Also, my spraying the pans, do I do that when, like, does mix together then spraying the pans? Do I take this and put that on the pans? No, I don't, right? So this is wrong. You can't do that. Same with preheat oven. Do I preheat the oven and then use that preheated oven to spray the pans? No, I do not, right? So what you're looking for in your algorithm is once I've done something, that something has to add to the next step. If there is something else that is happening on the side, it has to have its own little branch. It can't be like put together in that spot. So that's really important to remember while you're working with these algorithms. We're doing, like I said, we're doing recipes just because it's kind of an introduction to algorithms, and it allows you to say if, and it allows you to do the checking. So down here, I'm going to change my color here. So this here is if it says if. So if the recipe says if, this is when you're going to use an if statement. So it only separates once. It's not going to separate all the time. And if you're not going backwards, you're not going to go back to make balls and then go back to make balls, because if is not really what you're looking for. If it says something like check, this is check, right? Or it might say add more milk, like see if it does this, then add more milk, I continue to add milk until it is finished. If something says that, that is a loop, right? Because you do it once and then you do it again and then you do it again. If it's only a one-time thing, like rolling my chocolate chip cookies in chocolate chips, then that's only a one-time thing. So that's an if statement, okay? So there's a few of these things that you have to watch when you're working with algorithms, and just be very careful that you don't include them, because what's going to end up happening is it will look like I will see the errors, and then I will you'll end up losing marks for that. And we don't want to do that, because I'm here to teach you guys how to do this. So that's algorithm design. They obviously get a lot more complicated as you get more complicated mathematical equations and and just like even geomatics problems becomes a lot more complicated. So just take this as an introduction to this, and you will see a lot more of this in GIS when you're later, like in later times. But so today I've covered the branching, I've covered looping, and I've covered algorithms. So this is just a few more examples for you to watch and go by.